Yeah, good evening all. Now I would like to discuss some problems on superposition theorem. Okay, see here, from the given circuit calculate current flowing through 10 ohm resistor by using superposition theorem. Okay, by using superposition theorem. Okay, in superposition theorem, here he is not asking to verify the superposition theorem. Verify means you need to calculate first, you need to consider total 2 branches and calculate current flowing through 10 ohm resistor. After that, consider each source separately. After that, total current is equals to 2 cases current. Then only superposition theorem is satisfied. Here not required to do the first one. That means by considering two sources, here I no need to calculate current. Okay, that means by using superposition theorem, step 1, here the circuit is having only 2 sources, right? Hence 2 cases are possible. If the circuit is having 3 sources, then 3 cases possible. Okay, step 1 or case 1, 10 volt source is acting alone. Then the remaining source, 2 ampere source, is replaced by open circuit. Okay, then supply voltage will be 10 volts, 5 ohms, 10 ohms, 50 ohms, right? Current source is replaced by open circuited, right? 50 ohm, 5 ohm, 10 ohm, right? Minus plus 10 volts. Okay, now see here, this is open circuited, right? Open circuit in series with resistance is neglected. Then the equivalent circuit will be like this. Minus plus 10 volts, 5 ohm. I need to calculate here current flowing through 10 ohm, right? That means current flowing through 10 ohm is equals to current flowing through, I am indicating current flowing through 10 ohm dash. Okay, from by using Ohm's law, I equals to V by R equivalent, right? That is 10 by 5 plus 10. In series current is same, right? And current flowing through 10 ohm will be 10 by 15. That is 2 by 3 amperes. Okay, that is case 1. Okay, next case 2 or step 2. 2 ampere source is acting alone. Okay, 2 ampere source is acting alone. Then 10 volts source is replaced by 10 volt source is replaced by short circuit. Okay, that means primary side supply will be replaced by short circuit. Okay, 5 ohm, 10 ohm, 5 ohm, your current source will be okay, 5 ohm, 10 ohm, 50 ohm, 2 amperes, right? Now see here that means here current I know, right? That means current flowing through 50 ohm is 2 amperes. This 50 ohm is divided into, I am assuming, I1 double dash, I2 double dash. I2 double dash is nothing but current flowing through 10 ohm, right? By using current division rule, by knowing the total current, I can calculate current flowing through any parallel branch elements, right? In this case, if here resistance is present also, no problem, not present also, no problem. Okay, don't bother about this resistance. Okay, then here that means total current is I know, right? Here then I2 double dash I need to calculate current flowing through 10 ohm, that is I2 double dash is equals to, in parallel I can use current division rule to calculate parallel branch elements, that is I2 double dash is equals to total current, that is 2 amperes into, right, 2 amperes into opposite parallel branch resistance, that is 5 ohm, divided by sum of parallel branch elements. Don't consider this series value. 5 plus 10, that is I2 double dash is equals to 2 into 5 by 15. Again you will get 2 by 3 amperes. Okay, if you didn't remember this formula, means directly you can apply nodal analysis, then also you will get same answer. Okay, then by superposition theorem, total current flowing through 10 ohm is equals to, okay, first case current, that is current flowing through 10 ohm dash plus current flowing through 10 ohm double dash. See here, current flowing through 10 ohm double dash is nothing but I2 double dash. Okay, that is 2 by 3 first case current, second case current also 2 by 3, you will get 4 by 3 amperes is the answer. Okay, in this problem we are having one voltage source and one current source, right? Previous problem the circuit is having two voltage sources, right? Now we will solve another problem, it is having three sources. Okay, see here, calculate voltage across 2 ohm resistor by using superposition theorem. In statement only we discussed, right? By using superposition theorem we can calculate current flowing through any branch or voltage across any branch, right? That means here I need to calculate voltage across 2 ohm resistor by using superposition theorem. Okay, see here, this is the given circuit. Here I need to calculate voltage across 2 ohm resistor by using superposition theorem. Okay, that means observe the circuit. This circuit is having three sources, right? 10 volt source, 2 ampere source and 20 volt source. That means three cases are possible here. Okay, first case, 10 volt source is acting alone, right? 20 volt source is replaced by short circuit and 2 ampere source is replaced. This is current source, right? Current source is replaced by open circuit. Okay, now see here I can redraw the circuit. 10 volts as it is, 10 ohm, 20 ohm, 2 ohm, 3 ohm. Current source is replaced by open circuit, voltage source is replaced by short circuit, right? Now observe this circuit diagram. Here open circuit in series with resistance will be neglected, right? Then I can remove this branch also, right? Then the circuit will be minus plus 10 ohms, 20 ohms, right? And 2 and 5 are connected in series, right? Okay, after that at this junction apply KCL at junction V. All are outgoing currents based upon my assumptions. I1 dash plus I2 dash plus I3 dash is equals to 0, right? I1 dash is equals to V minus 10 by 10, I2 dash is equals to V minus 0 by 20, I3 dash is equals to V minus 0 by 7, right? Then if I simplify this equation, V is taken as common, 1 by 10 plus 1 by 20 plus 1 by 7 is equals to minus 10 by 10 is nothing but minus 1. If I take it into RHS side, you will get plus 1, right? Then after simplification you will get V value as 3.41 volts. Okay, by knowing this V value, here I need to calculate current flowing through 2 ohm, right? Based upon my assumption, current flowing through 2 ohm is I3 dash is equals to V by 7, right? That value is 0.487 volts. But in the problem he is asking voltage, then voltage across 2 ohm is nothing but I3 dash into 2, that means current flowing through that branch into that branch resistance, right? Then we will get 0.487 into 2, we will get 0.97 volts. Okay, that is voltage across 2 ohm, first case V 2 ohm dash. Okay, similarly case 2, in case 2 20 volt source is acting alone, right? That means this source is acting alone. Again this is replaced by open circuit, this is replaced by short circuit. Okay, first source is replaced by short circuit Again this is replaced by open circuit, right? When it is replaced by open circuit in series with resistance neglected, right? Then the equivalent circuit will be like this: 2 ohm and 5 ohm are connected in series with a battery voltage of 20 volts. Okay, again apply KCL at this junction V. I1 double dash plus I2 double dash plus I3 double dash is equals to 0. Okay, I1 double dash equals to V minus 0 by 10. Okay, I2 double dash is equals to V minus 0 by 20. I3 double dash is equals to V minus 20. V minus 20 by 2 plus 5, 7, right? If I simplify this equation, I will get node voltage value as V is equals to 400 by 41 volts. Okay, after that, here I need to calculate I3. I need to calculate first current flowing through 2 ohm, right? That is nothing but I3 double dash. I3 double dash is nothing but V minus 20 by 7. V value will be 400 by 41 minus 20 by 7. I will get I3 double dash value will be minus 1.46 amperes. Then voltage across 2 ohm resistor is nothing but I3 double dash into 2, and I will get minus 2.92 volts. Okay, clear, right? Next, what is the third case? Third case is we need to consider 2 ampere sources acting alone. These two sources are replaced by short circuit, right? You can observe here the primary source is replaced by short circuit, that is 10 volt source, and here 20 volt source is replaced by short circuit. Okay, now the circuit is having two junctions, right? Okay, that means apply KCL at junction V1 and apply KCL at junction V2 and calculate current flowing through 2 ohm resistor, right? First, that is here I1 triple dash plus I2 at this junction V1, I1 triple dash plus I2 triple dash plus I3 triple dash equals to 0. That is I1 triple dash plus I2 triple dash plus I3 triple dash is equals to 0. That is V minus 0 by 10, V1 minus 0 by 20, V1 minus V2 by 2 is equals to 0. That is V by 10 plus V by 20 plus V1 by 2 minus V2 by 2 is equals to 0. Okay, if I take V1 as common, 1 by 10 plus 1 by 20 plus 1 by 2 minus 0.5 V2 is equals to 0. If I simplify this equation, I will get 0.65 V1 minus 0.5 V2 is equals to 0. Similarly, apply KCL at junction V2. I will get I4 double dash plus I5 double dash plus I6 double dash is equals to 0. Right? I4 double dash plus I5 double dash plus I6 double dash is equals to 0. Okay, I4 double dash is nothing but V2 minus V1 by 2. V2 minus V1 by 2. I5 double dash is equals to, see here I5 double dash, that means here current is given, these two are opposite to each other, right? Then I5 double dash is equals to minus 2, that is minus 2 plus I6 double dash is equals to V2 minus 0 by 5. Okay, I2 double dash is equals to V2 minus 0 by 5, that is V2 by 5 plus, V2 by 2 plus V2 by 5 minus V1 by 2 is equals to 2. If I simplify this equation, I will get minus 0.5 V1 plus 0.7 V2 is equals to 2 volts. Okay, by solving equation 1 and 2 in calculator, equation 1, equation 2, you will get V1 as 4.87 volts and V2 as 6.34 volts. Okay, but I need to calculate, just see here, I need to calculate current flowing through 2 ohm, that is either I3 double dash or I4 triple dash, I3 triple dash or I4 triple dash. Here I am considering I4 triple dash, that is your wish, that is V2 minus V1 by 2. If I simplify this equation, I4 double triple dash value will be V2 minus V1 by 2, that value will be 0.73 amperes. Then voltage across 2 ohm triple dash is equals to current flowing through that branch into that branch resistance. I will get 1.46 volts. Okay, then by using superposition theorem, okay, total voltage will be voltage across 2 ohm dash plus voltage across 2 ohm double dash plus minus of voltage across 2 ohm triple dash. Okay, why you are getting minus? Just observe here. First case. Okay, first case, while calculating voltage across this 2 ohm resistance, the direction of current is outgoing. Okay, case 2 also, the direction of current is outgoing. Okay, in case 3, I am considering this voltage. While considering voltage value, the current direction is opposite when compared to previous two cases, right? Okay, that means first two cases I am assuming positive, hence for third case voltage I am assuming negative. Otherwise, if you consider in place of I4 triple dash, if you consider I3 triple dash, okay, then you will get here positive. Okay, after simplification I will get total voltage V value will be minus 3.41 volts. Okay, in this way we can solve the problems on superposition theorem. Okay, thank you all.